Hello everyone. I welcome you all for today's session on electromagnetic wave 18EC55, Module 1, Coulomb's law, electric field intensity and flux density, Lecture 2. I am your friend Mahadev, Assistant Professor, Department of ENC, Gaussian College of Engineering, Ramnagaram. Before going to the detail, if you're not subscribed to my channel, subscribe to my channel, click on the bell icon for further notification or share with your friends for their benefits. First, let us see the content, what we are going to see in today's session about field due to continuous volume charge distribution. And the second one is about field of line charges. That is, what is the electric field intensity due to field due to continuous volume charge distribution and the line charge. First, let us see field due to continuous volume charge distribution. What is the meaning of that? Now, if you observe a random shapes, what we have here, and in this, the charges are distributed continuously here. And in order to calculate the electric field intensity of this particular charge over the point P, we need to see the effect there. So if the charge distribution is such that the charges are distributed continuously in a volume, then it is referred to as volume charge density there. And it is denoted by rho V. Rho is defined as volume charge density, that is charge per unit volume. So rho V is del Q by del V. So mathematically, by using the limiting process for the above expression, we can make the volume shrinking to 0 there. That is limit of del V is equal to tends to 0, del Q by del V. This is the second equation. So but total charge within some finite volume is obtained by integrating throughout that volume. Okay, so if you observe, bring this del V to the left hand side here, and the del, when you take it to the other side, it becomes the integration there. So we get the charge value. So that's what is the expression what is given here. The total charge is given by integration of volume of rho V over the volume dV. So this is how we find the total charge present inside that particular volume there. But we have electric field intensity at a point P due to the point charge is given by del E is equal to del Q by 4 pi epsilon R square into AI. There's a unit vector. So from figure, we can see the charge distribution is continuous and the field at a point due to the entire volume charge distribution. If you see in the figure, what is the effect of all these charges at the point P? We have to observe and we need to calculate the electric field intensity at the point P there. Okay, so now here, E is given as volume integration of del E there. So what is del E? Del Q divided by 4 pi epsilon R square AR, because we know the formula for the electric field intensity, and since it is del E, it is del Q. But what is del Q? It is rho V into dV. So substitute that. So rho V into dV, we have substituted del Q value. Now since it is integration over the volume, okay, so take the other terms outside. So it is rho V by 4 pi epsilon naught volume integration, okay, 1 by R square AR dV. So this is the electric field intensity due to the continuous volume charge distribution there. So in the examination, they may ask. Next, what we have is field of line charges. So what is the field of line charges? Now observe here, consider an infinitely long straight line carrying a uniform line charge having the line charge density denoted by rho L. If you observe the charge, respect to charge density is given by rho, and if it is volume, it is V. If it is line, it is L, and if it's surface, it is S. So it is, there is a rho L is centimeter per meter there. Now let the charge on every short segment, what we have, the differentiation, dl of a line BQ here. So what happens, now if I consider a small differential length dl, then the charge for that particular dl is given by dq. So line charge density is given by rho L is equal to dq by dl, or dq is nothing but rho L into dl there. Okay, so dq is rho L into dl, what we have just written it. Now we need to see the effect of this line charge density on the point P, which is at a distance of r from the origin there. Now we have to draw a line from the differential length dl to this particular point P. Okay, and we need to find the electric field intensity of to this particular at point P due to the line charge. Now, if you observe, if it is moving here, so we get a resultant electric field intensity, one in the y direction, another in the x direction there. Okay, so now we need to calculate the electric field intensity at point P there. Now let us calculate the electric field intensity at a point due to an infinite long state conductor, that is line charge varying from minus infinity to plus infinity here, this particular line charge. Now let P be the point on the y-axis at which the electric field intensity is to be determined, and R be the distance of point P from the origin as shown in the figure. So if you observe, let P be the point on the y-axis, what we have denoted, and the distance between that is R. So now let us calculate the electric field intensity at a point P due to the entire line charge present on the z-axis. So whatever the line charge is present on the z-axis, we need to see the effect of this particular thing on the particular point P. Now let us consider a small differential length on the z-axis at a distance of 0, 0, z, because it is present on z-axis, only z parameter will be present, and dq is given by rho L dl as we already seen it, and but dl is what? Differential length is what? Differential in the z-axis, so it is dl is dz, so replace dl with a dz, so dq is rho L dot dz. That's be the equation 3. Now from figure, dq has coordinate of 0, 0, z, and point P has a coordinate of 0, r, y. Now what is the distance between the differential length dz to the point P? If you see, the distance is given by r ay minus z az in the respective direction. As we know the distance, how it is calculated, difference between the 2 points. So it is how, if you observe, destination is 0 minus 0 x, there is no value, r minus 0, so it is r ay minus 0 minus z, that's why it is 0 minus z az. So this is the distance of a point P to the del Q, that's a small differential length. Modulus of r, what is that modulus of r? Taking the square of that particular term, and unit vector is given by r by modulus of r, so it is r ay minus z az divided by square root of r square plus z square. Okay, this is a unit vector formula. Now if you observe that electric field intensity at a point charge is given by del E is equal to del Q divided by 4 pi epsilon naught r square ar. Now we need to substitute the value of r in this particular and the unit vector ar. So what we get? So del Q is equal to what? Del Q is what? Rho L dz divided by 4 pi epsilon naught r square, we have kept that is unit vector, we have substituted r ay minus z az divided by square root of r square plus z square. Okay, but what is r? R is modulus, so it is r square plus z square. So when you combine the denominator here, it becomes what? R square plus z square 3 by 2. Okay, so del E is rho L dz r ay minus z az divided by 4 pi epsilon naught r square plus z square whole to the power of 3 by 2 there. Okay, now we need to see the important analysis here. What is the known? Since the line charge on the z-axis is symmetry to the y-axis, as we can see in the particular figure, so z-axis is symmetry to this particular y-axis. Okay, so what happens? The electric field energy produced by all charges get cancelled. Hence, there are no z component for the above equation. As since it is symmetric, one axis above the y-axis is positive and the other one is the negative, so it gets cancelled. So the z component becomes 0 there. So now in the expression, we can remove the z parameter, and what is left is only ay term. So del E is rho L divided by 4 pi epsilon naught r ay divided by r square plus z square is to 3 by 2 dz. Now the above equation gives the electric field generated by small charge q over the length, that the net electric field intensity is given by integrating over the entire length. Now this is for that particular smaller length. Now for the entire line, if you want to calculate, we just need to perform the integration over minus infinity to plus infinity for the above equation. Just taking the integration to the del to the other side, it becomes integration. So minus infinity plus infinity rho divided by 4 pi epsilon naught r ay divided by r square plus z square raised to 3 by 2 dz. So from the figure, we can see what? Tan theta is given by r by z. If you observe here, tan theta is R by Z. Okay, to get the parameter of R and Z there. And cot theta is Z by R, just a reverse of tan theta there. So if you see, Z is given by R cot theta. Now differentiating the above equation, this one, with respect to theta, we get dz is equal to minus R cosecant square theta d theta. Differentiation of cot is minus cosecant square theta. Now substituting the limits, now since it is minus infinity and plus infinity, because we are having the term replacing Z with terms of theta there, so we need to change the limits. So Z is equal to minus infinity. So it is what theta is, cot inverse of minus infinity is pi, and Z is equal to infinity is cot inverse of infinity is 0 there. So finally, the integration changes from E is equal to pi to 0, rho L by 4 pi epsilon R divided by R square plus Z square raised to 3 by 2 dot dz ay. Now substituting the R value in the above equation, what we get? It is minus R cosecant square theta, because dz is what? Minus R cosecant square t theta d theta. Okay, now Z is what? R cot theta, so it is R square cot square theta. Take R square common, so R square 3 by 2 into 1 plus cot square 3 by 2 here. So 2 gets cancelled, so it becomes R cube, and 1 plus cot square becomes cos square theta there. And this negative term is taken here. So E is minus rho L ay divided 4 pi epsilon naught integration from pi to 0. So R square cos square theta divided R cube cos square theta 3 by 2. So here square get cancelled, cube and square terms gets cancelled there. So what happens in the next integration? So above square and denominator cube get cancelled. So left is what? 1 by cosecant. 1 by cosecant is sine. So integration of sine is what? Minus cos. And the limits from pi to 0. When you substitute this particular value, pi to 0, this minus and this minus becomes positive there. So it is cos theta 0 to pi. So after substituting the value of the limit, so cos 0 minus cos pi, we get 2. So 2 and this 4 get cancelled, it is 2. So E is equal to rho L by 2 pi epsilon naught R into Ay. So this above equation is the electric field intensity due to the infinite long straight conductor. So this is how we find the field for the entire line charges. If you have any questions, go to the comment section, write down your questions. I will reply to your question. If you're not subscribed to my channel, subscribe to my channel. Click on the bell icon for further notification, or share with your friends for the benefits. Thank you.